Good morning, children. Today we are going to start a new chapter, that is the electricity. It is a very interesting topic because you deal with this topic in everyday life. Okay, and now there is a condition like we cannot survive without this electricity, correct? The phone is discharging, mama, my phone is discharging, when the light will come? Okay, so electricity is very important factor in your life now, correct? So I think you need to study this, how this electricity is generated, from where this electricity is coming, correct? So what is exactly this electricity is? Okay, so we are going to study this electricity in this chapter number 12. Okay, before starting this chapter we will revise some points. Okay, so what are the conductors? You have studied this in the previous standards. So the conductors are those materials that allow flow of electricity through them. They can conduct electricity because of the presence of free electrons between the atoms of the substance. I'm just reading this because you have gone through these topics in your earlier grades. Okay, all the metals are the good conductors of the electricity, and graphite, that is the only non-metal, can also conduct the electricity. Next we have the insulators. Insulators are the opposite of conductors, that is, those do not allow the flow of electricity through them. They cannot conduct electricity because they don't have free electrons between their atoms. All the non-metals except graphite are the insulators. Next, now electricity. Now what is this exactly, the electricity? It is having a charge, correct? Electric charge. So when this charge is going to produce, so when a glass rod is rubbed with a silk cloth, it acquires the ability to attract small particles of paper and is said to have acquired an electric charge. Okay, you have done this experiment many times. You take a silk cloth, rub on a glass rod, and then take it near a paper. You see that the glass rod attracts the small particles, or it can attract a paper towards it. So the glass rod has acquired an electric charge. The SI unit is coulomb, and that's the symbol of coulomb is capital C. So now, what is electric current? Okay, the electric current is a flow of electrons through a conductor. The device which causes the flow of electrons through a conductor is called a cell. Correct? You have the cell in your remotes, in your what you can say, the remote cars and all. Okay, the also in your watch also. So that is the device which causes flow of electrons through a conductor is called a cell. Electrons flow from a negative terminal to a positive terminal. Electric current flows from a positive terminal to a negative terminal. This is called conventional current. Conventional means what? मेरे मर्जी के हिसाब से मैं चलूँगा. That is conventional current. He feels now I should go from negative to positive. He goes from negative to positive. Then again he comes from positive to negative. This is called conventional current. Now electric current is expressed as the rate of flow of charges through a conductor, or a quantity of charges flowing through a conductor in a unit time. Q is related to quantity of charge, and therefore I, that is current, is equal to Q upon T, that is quantity of charge upon time. The SI unit is coulomb. It is a charge contained in 6 into 10 raised to 18 electrons. Okay, this is, you don't have to remember, but just for your knowledge I have given over there. The charge contained is 6 into 10 raised to 18 electrons in one charge. Okay, the SI unit of current is called ampere. Okay, SI unit of electric charge is coulomb, but SI unit of current is called ampere. Okay, the 1 ampere is a current flowing through a conductor if 1 coulomb of charge flows through it in a 1 second. That is, 1 ampere is equal to 1 coulomb of charge must pass in 1 second. Then it is known as 1 ampere. Electric current is measured by an ammeter. It is always connected in series in a circuit. see over here, you can see the electricity is a flow of electrons around a circuit. You can see the electron E flowing in a directional and unidirectional way also. Okay, so that is, the battery is given, the lamp is given, the lamp will light when the current is flowing. Okay, so now what is electric potential and the potential difference? Electric current will flow through the conductor only if there is a difference in the electric potential between the two ends of the conductor. And this difference in the electric potential between the two ends of the conductor is called the potential difference. Okay, the difference between the two ends of the conductor. Okay, that is known as that is initial charge, electric charge, and the end electric charge is known as and the difference between that is known as the potential difference, and this is a very important factor in the electricity. Okay, the potential difference in a circuit is provided by a cell or a battery. The chemical reaction in the cell produces a potential difference between the two terminals and sets the electrons in motion and produces electric current. So here in general what I can say, what you can say, they give in Hindi you can say तो टोचन लगाता है वो. Okay, come on move, this the cell or the battery in your object gives the command that now you have to, they command over the electrons, and this command over the electrons is known as potential difference. Okay, so the potential difference between 2 points A and B of a conductor is the amount of work done to move a unit charge from A to B. Okay, the work done from A to B needs a unit charge, and this unit charge is known as potential difference. That is, potential difference is equal to work done upon charge, or V is equal to W upon Q, and the SI unit is volt. Okay, 1 volt is a potential difference when 1 joule of work is done to move a 1 charge of 1 coulomb from one point to the other. That is 1 joule upon 1 coulomb, and it is measured by the voltmeter, and it is always connected in a parallel series. Okay, which the potential difference is to be measured. In the ammeter it was connected in the series, and in the voltmeter it is connected in the parallel. Okay, so why this potential difference is important? Because electric current will flow through the conductor only if there is a difference in the electric potential between the two ends of the conductor. The potential difference in the circuit is provided by a cell or a battery. The chemical reaction in the cell produces the potential difference between the two terminals and sets the electrons in motion and produces electric current. Correct? So why potential difference is important? Because if there is no difference in the potentials at the two ends, where the electrons are going to flow, the direction will be, how the direction will be determined? The potential difference will determine the direction, right? If this is a A point and this is a B point. Okay, so here the electrons are very less and here the electrons are very more. Okay, so where the electrons are needed, here the electrons are needed. So what the cell or battery will do, they'll tell, okay electrons, come on, you have to go to the A. Okay, so flow will direct from B to A. Okay, so in this way the circuit will start the flow of electrons, and this is why the potential difference is needed. Next we have the electric circuit. Okay, so electric circuit is a continuous and closed path of an electric current. So here there is a diagram over there of an electric circuit. Okay, you can see over there the cell, that is plus and minus, positive and the negative terminals. The bulb is given, the ammeter is given where you can measure the current. Then there is a plug key, that is the open or the close, and you can see the arrows over here. Correct, you can see the arrows over here. Okay, you can see the arrows, that is the direction of the current. Okay, direction of the electrons, that is the direction is from the positive to the negative. Correct, see it is moving like this. The electrons are moving from positive to negative terminal. Okay, so here are the symbols for the components which are used in the electric circuit. First one is the electric cell. Okay, electric cell, the battery or the single cell is denoted by plus or minus, that is the plus point and the minus point. Next is the plug or a switch. Here it is closed one, here it is open. Then there is an electric bulb. Then this is a resistance, okay, resistance or a rheostat we can say. Okay, then there is an ammeter. Then there is a wire joint. Okay, if the wires are joined perpendicular, then it is given over there. Then there is a combination of cells, that is one or two or three cells if it is given. Then there are the combination of battery or a combination of cells. Then there is a closed switch. Okay, next we have a resistor or a resistance. Then there is a rheostat, when the arrow over it means what, there is no resistance. Then this is a voltmeter, and this is a wire crossing over without join, the two wires are kept over each other. Okay, so what is now voltmeter? A voltmeter is a device that measures the potential difference across the ends of any conducting material. It is connected in parallel to the ends of the conducting material, and it has a high resistance. Okay, so where you need a high resistance, there is a voltmeter. An ammeter is a device that measures the current flowing through any conducting material. It is connected in series, and it has a very low resistance. So what main different points we have to remember in voltmeter and ammeter is that voltmeter measures the potential difference, ammeter measures the current flowing through it. Then the voltmeter is connected in the parallel, and the ammeter is connected in the series. And then voltmeter has a high resistance and ammeter has a low resistance. Okay, so till now we have covered about the what is electric current. In the next video we are going to see about the great person, the Ohm, okay, who has introduced the Ohm's law. Okay, thank you children.